Hello everyone, I'm Varsha studying Computer Science and Engineering in Sri Venkateswara College of Engineering. Today's video is about Introduction to Stack, Stack Operations and Implementation, Stack Implementation using Arrays, Stack Implementation using Linked List, Application of Stack, Advantages of Stack, Application of Stack in Real Life. Stack. A stack is a linear data structure in C programming that operates on the principle of first in, last out. In this presentation, we will explore the definition of stack, its operation, and its common applications. Stack operations in C programming. Push. Push is an operation, adds an item to the stack. If stack is full, then it is said to be an overflow condition. Algorithm for push. Begin if stack is full, return. End if else, increment top stack of top, assign value, end else end procedure. Pop is an another stack operation. Removes an item from the stack. The items popped in the reverse order in which they are pushed. If stack is empty, then it is said to be an underflow condition. Algorithm for pop. Begin if stack is empty, return, end if else, store a value of stack of top, decrement top, return value, end else, end procedure. Top returns the top element of the stack. Algorithm for top. Begin, return stack top, end procedure. Display operation of stack. Display operation shows all the elements in stack without modifying the stack. Algorithm for display. Display top of a of I. If top is equal to 0, then print stack empty. Exit else for I is equal to top to 0. Print a of I. End for exit. Is empty operation returns true if stack is empty, else false. Algorithm for is empty. Begin if top less than 1, return true, else return false, end the procedure. Stack implementation using arrays. Array representation of stack. Arrays can be used to represent a stack where the top of the stack is the index of last element. Stack operation using arrays. Arrays provide efficient push and pop operations, but resizing the stack can be challenging. Pros and cons of array implementation. Array-based stacks have constant access time but limited capacity. Stack implementation using linked list. Linked list representation of stack. Linked list can be used to represent a stack where each element points the next element. Stack operations using linked list. Linked list allows dynamic resizing of stack but has slightly slower access time. Pros and cons of linked list implementation. Linked list based stacks have flexible capacity but require extra memory for storing pointers. Common application of stack. Function calls and recursion. When function is called, then the current state of the program is pushed into the stack. When function returns, the state is popped from the stack to resume the previous function's execution. Redo and undo operations. Undo and redo feature is a various applications uses stack to keep track of previous actions. Each time action is performed, it is pushed into the stack. To undo action, the top element of stack is popped and reverse operation is performed. Expression evaluation. Stack data structure is used to evaluate the expression in infix, postfix, and prefix notation. Operators and operands are pushed into the stack and operations are performed based on the stack's top element. Browser history. Web browsers uses stack to keep track of web pages you visit. Each time you visit a new page, URL is pushed into the stack, and when you hit the back button, previous URL is popped from the stack. Balanced parenthesis. Stack data structure is used to check if parenthesis is balanced or not. An opening parenthesis is pushed into the stack and closing parenthesis is popped from the stack. If stack is empty at the end of the expression, parenthesis is balanced. Backtracking algorithms. Backtracking algorithm uses stack to keep track of states of problem solving process. Current state is pushed into the stack. Algorithm backtracks the previous state of pop from the stack. Advantages of stack. Easy implementation. Stack data structure is easy to implement using arrays or linked lists, and its operations are simple to understand and implement. Efficient memory utilization. Stack uses contiguous blocks of memory, making it more efficient in memory utilization as compared to other data structures. Fast access time. Stack data structure provides fast access time from adding or removing the elements as elements are added and removed from the top of the stack. Helps in function calls. Stack data structure is used to function calls and their states, which helps in efficient implementation of recursive function calls. Supports backtracking. Data structure supports backtracking algorithm which are used in problem solving to explore all possible solutions by storing the previous states. Used in compiler design. Stack data structure used in compiler design for parsing and syntax analysis for the programming languages. Enables undo and redo operation. Stack data structure is used to enable undo and redo operations in various applications like text editors, graphic design tools, and software development environments. Application of stack in real life. CD DVD stand, stack of books in bookshop, call center systems, redo undo mechanisms in text editors. The history of web browsers is stored in the form of stacks. Call logs, emails, and Google Photos, any gallery are stored in the form of stack. Allocation of memory by operating system while executing a process. Thanks for watching the video.